Hello, pre-calc students. This is Mr. Beck. Today we're going to be talking about the graphs of secant and cosecant. The way that we're going to look at the graphs of secant and cosecant is we're going to look at the graphs of sine and cosine. So what I do have at the top, I have all of our known trig ratios. Those ratios in this case for cosecant. And these are for the special angles, the 0, the pi over 6, pi over 4, pi over 3, and pi over 2. What I've done is I've converted each of them to decimal form and graphed them appropriately. And so when I did that, one of the big things that we need to look at is where's cosecant undefined. And so this is where we're going to take a look at the graph of sine. So if we remember for our graph of sine, from our equilibrium, which in this case is 0, sine goes from 0 up to 1, down to 0, down to -1, or back up to 0. So basically 0 peak, 0 trough, 0. Wherever sine was 0, cosecant is undefined because the reciprocal of 0 is undefined. So the first thing that we're going to do is we're going to look at these undefined values. So then, if you reciprocate a number between 0 and 1, you get a number between 1 and infinity, which is why the sine graph reciprocates into what looks like this parabola. It's not actually a parabola, but it sort of looks like a parabola, and we can kind of think about it that way. Then if you reciprocate a number between 0 and -1, it becomes a number between -infinity and -1. Hence, that's why our range is from -infinity to -1, and then from 1 to infinity. Now, I do want to look at domain. The domain, the way we're going to establish domain, we are going to look at the first value. We're going to say, what is x not allowed to equal? So this is sort of like a set notation. What is x not allowed to equal? What I want you to do is I want you to list for me one asymptote. So give me just one of these asymptotes that we have here. In this case, I have 0 listed. Now we are going to have a pi in front because pi is the distance between asymptotes. So the way we're going to look at this is, okay, we're going to establish x is not allowed to equal one of these asymptotes, and then the distance between them times n. Now n represents an integer. So this is a common thing that we look at. N is an integer. So if n is 2, x is not allowed to equal 0 plus 2 pi, and we actually see that right here. If n equals 4, x is not allowed to equal 0 plus 4 pi, which if we went one full period, we'd see that over here as well. So we're not going to necessarily have all the same answers. You could really say x cannot equal pi plus pi n. This is going to be true because pi is one of the asymptotes, as we see right here, plus pi n. Now, these statements do mean the same thing mathematically. I just want you to establish, give me one asymptote, and then what's the distance to the next asymptote, and write it as a statement that way. One asymptote, and then the distance to the next one. The other important thing that we need to look at is the amplitude. Notice how I have none for the amplitude, and that is because amplitudes are really established as the average of the highest point and the lowest point. And since the highest point and the lowest point are infinity and negative infinity respectively, we can't really definitively say what that average is. So we say there's no amplitude. The amplitude is really only a thing for sine and cosine. Our typical period is 2 pi, and the reason why our typical period is 2 pi is because when we reciprocate the sine function's period is 2 pi, so cosecant is 2 pi as well. So, as I said, the way that we're going to graph, we're going to first establish, we're going to establish the graph of sine or cosine, and then where sine has a 0, secant and cosecant are going to have asymptotes, or the vertical asymptotes. And then the peak and trough of sine and cosine, we're going to establish those as relative magnitudes. So if we look at problem number 5, first thing I look at is for cosecant of x. I know that cosecant is a reciprocal of sine, so I'm going to graph sine first. So for this graph of sine, I notice that my equilibrium, so the first thing I look for is equilibrium. That's not really a bad thing for us to establish what order we are going to be doing everything in. So the very first thing I'm going to look for is equilibrium. The second thing I'm going to look for is what is my beginning and what is my end. The third thing I'm going to look for is then I have to cut it into fourths. So cut into fourths so we can establish what's happening with all the quadrantals like we did last time. The fourth thing we are going to do then is we are going to graph the positive or negative sine or cosine. And then from that, we will reciprocate. Reciprocate. There you go. All right, I think I did that properly this time. So what I left a lot of this blank for us, or at least at the beginning, so we could establish just how I'm going to write them, and I do want to show some of that. But anyway, let's go back to, we have equilibrium. Now from our equilibrium, we're going to establish our start. Because there are no modifiers here, sine typically starts at 0, and sine typically, so start, then sine typically ends at 2 pi. So that's actually what we're going to do here. We're going to start at 0, end at 2 pi, then cut it into 4 equal parts. 4 equal parts is very nice on this graph right now. So some of the graphs aren't going to be quite so nice, but sine is going to be nice on this graph. So then our sine graph is going to be 0, peak, 0. Let me change highlighter colors on here. 0, peak, 0, trough, 0. Notice how I am going by the amplitude of 4 for the sine graph. So our amplitude of 4 for the sine graph. Then wherever sine was 0, we're going to create our vertical asymptotes. So vertical asymptote, vertical asymptote. And then we reciprocate the sine into that parabola shape. So our first asymptote that we have here, our first asymptote is x equals 0, so x is not allowed to equal 0. And then for the next asymptote is at pi, so x cannot equal 0 plus pi n. Our period's 2 pi, and we know that because there is no b value. Now officially, our period is 2 pi divided by the b value. So I said no b value, but the b value is really 1. So our period is 2 pi divided by 1, which is 2 pi. Now we know we didn't have a coefficient other than 1 for the b. Because we didn't have that, then our period should still be 2 pi. Our range, negative infinity to -4, and 4 to infinity. We could see that easily on the graph. And as we said before, there's no amplitude. So on this next one, the very first thing we're going to look at is, what is my vertical shift? My vertical shift is 2. Second thing I'm going to look for is, where do I start and where do I stop? So x equals 0, and then x equals 2 pi, which I'm going to go ahead and say x equals 0 and x equals 2 pi. So from beginning to end right there. Then this is the graph that's going to model the 3 cosine. So if you remember, cosine starts at the peak, peak 0, trough 0, peak. So this is the cosine graph that I am going to be following. Now typically for our cosine graph turning into the secant, we do go back a quarter of a period just so that we can have what almost looks like sine graph, so that we can have like a full positive U shape going up and a full positive U shape going down. So then we reciprocate and we reciprocate, and it's just that easy. All right. First asymptote that I see here is pi over 2. So x is not allowed to equal pi over 2. And then the distance between asymptotes is pi. So x cannot equal pi over 2 plus pi n. Our period for this one, once again, is 2 pi, and that's because there is no b value. There is no number other than 1 in front of the x. Our range, we can see from the graph, negative infinity to -1. That -1's right here, and then from 5 to infinity. And no amplitude, of course. For this graph, this is going to be the first one that does have a b value modifier. I'm going to go ahead and actually talk about that right now. So this b value is 1/2, so our period is 2 pi over 1/2, which is 4 pi. I'm going to go ahead and list that there. That's nice to know in advance, but at the same time, we should be able to see that from the graph, and I'll show you why. So kind of like before, first thing we're going to look at is our vertical shift. Our vertical shift is 4. Second thing we're going to look at is, where does x over 2 equal 0? And where does x over 2 equal 2 pi? So that would be x equals 0 and x equals 4 pi, because that's our beginning and our end. And it's right there, x equals 0 and x equals 4 pi. We should be able to see the distance from here to here is 4 pi. So that just reinforces what we knew algebraically from the 2 pi divided by b. So then our positive cosine, this is actually a negative cosine that we're going to look at. So the -2 cosine would go trough, 0, peak, 0, trough. And then we reciprocate those values. So the trough reciprocated. Oh, actually, I guess the first thing I should do is look at wherever these end up crossing the equilibrium so we can have our vertical asymptotes, and then we reciprocate it. I jumped the gun on that one, I apologize. So establish one of our asymptotes. I see this asymptote right here is pi, so x is not allowed to equal pi. And then the distance from one asymptote to the next asymptote is 2 pi, so x is not allowed to equal pi plus 2 pi n. I did sort of jump over putting these on a scale, putting these accurately on the scale for the graph. If we have 0 and we have 4 pi on our graph, it makes sense to go by pi's. So I apologize for jumping over that. But anyway, our range we can see on the graph goes up to the positive value of 2, and then from 6 to infinity. And of course, no amplitude. Continuing on, first thing that I'm going to look for is what is my vertical shift? Vertical shift is down 1. The second thing is where do I begin and where do I end? So I began at x equals negative pi over 4, and I end at 7 pi over 4. So how do I graph negative pi over 4 and 7 pi over 4 on the graph nicely? Well, that's by a scale of pi over 4 in my opinion. I hope you guys agree with that one. So negative pi over 4 to 7 pi over 4. And I have 8 boxes in between. And if you remember last time we talked about graphing, 8 boxes. So we're going to have to cut that in half first, 4 boxes, and then cut that in half. So you can break that into 4 equal parts. So this is going to model a negative sine function because sines are reciprocal of cosecant. So we go 0, trough, 0, peak, 0, and that amplitude of 3 for the sine graph. Then wherever sine was 0, we have asymptote, 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 and then we reciprocate the trough, we reciprocate the peak. So our first asymptote, we started at x equals negative pi over 4. And then from here to here, that distance does equal pi. In case you want to double check, you could say, okay, what is 3 pi over 4 minus negative pi over 4? That does equal pi. So that establishes that the distance between asymptotes is indeed pi. So negative pi over 4 plus pi n is what we cannot include. Our period does equal 2 pi. And as you see right here, this is how I sort of checked. I ended at 7 pi, I began at negative pi over 4. So if we subtract those, we do get 8 pi over 4, which is 2 pi. Now we could also check by saying our period is 2 pi divided by our b value of 1, which is again 2 pi. So we can visually see it 2 pi, we can algebraically see it as 2 pi, and we can count to get 2 pi. Range is negative infinity, negative 4 to infinity. Hopefully we could see that. Negative infinity to negative 4, and then from 2 to infinity. And no amplitude. For the graph of E, if I first say there is no vertical shift, so equilibrium is 0, x minus pi over 3 equals 0, and 2 pi to establish my beginning is pi over 3, and my end is 7 pi over 3. 7 pi over 3. How do I get pi over 3 and 7 pi over 3 on the graph nicely? I'm just going to have to add another box there. So my beginning is here, my end is here. And this models a positive sine or cosine function, so with an amplitude of 5. So cosine goes peak, 0, trough, 0, peak. Now notice I kind of skipped over the cutting into fourths. I have 6 boxes in between beginning and end. So halfway in between is 3 boxes, and then halfway is 1.5 boxes. Not the prettiest looking thing that we are looking at, but at the same time, we're going to encounter some nasty fractions. I'm sorry, but it's true. So peak 0, trough 0, peak, and then I reciprocate my zeros, which if I go backwards 1.5 boxes, I also get this as a asymptote. And this is negative pi over 6. I know that because that is half of pi over 3. So x cannot equal negative pi over 6, and then the distance from one asymptote to the next is pi, if we count. Now, a shorthand way of looking at this, I'm not sure if you guys have caught on just yet, but a shorthand way of looking at this is the distance between asymptotes is always going to be half of the period. So if you notice, pi is half of 2 pi. pi is half of 2 pi. 2 pi is half of 4 pi. Pi is half of 2 pi. Once again, pi is half of 2 pi. So your shorthand way of looking at this is, let's just go half the period to the next asymptote. Range, bottom value is -5, or really the top there is -5. And then the relative minimum here is from 5 to infinity with amplitude of nothing. One more time. So vertical shift to -1. Then where do I begin? Set what's inside equal to 0 and then to 2 pi. So I begin at -3 pi over 2 and I end at pi over 2. So that tells me I really want to go by a scale of pi over 2s just to make life easier on myself. This models a negative sign function. So 0, trough, 0, peak, 0. And that sign function has an amplitude of 4. And then reciprocate my zeros, reciprocate my asymptotes, and I'm good. One asymptote that I have here, I chose pi over 2. Now I could have just as easily said x is not allowed to equal -pi over 2 plus pi n. That's going to be true as well. So multiple ways that we can write it. I will accept any and all of those answers that are correct. And then the distance is, if half the period. Notice how I don't have a b value. I don't have a coefficient other than 1. So my period should still be 2 pi, hence pi n for my domain. Range, -infinity, -5, and then 3 to infinity, and then no amplitude. And then when we throw all of our pieces together, so if we throw all of our pieces together, on this one, there is no vertical shift. We see that. Set what's inside equal to 0 and 2 pi, and that gives us x is pi over 4 and 3 pi over 4. So I need to put pi over 4 and 3 pi over 4 on here appropriately. Please, 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 don't just say, don't just put it as small of a graph as possible. I know I talked about that in the last time's notes. So if I want to put pi over 4 and 3 pi over 4 on here, I can scale that nicely. If I go by pi over 8, then this models a positive cosine function. As a positive cosine function, I probably should have made this a little bit taller, or at least scaled that by 1. Anyway, positive cosine function goes from peak, 0, trough, 0, peak. And like most of the cosine functions, we go back a quarter of the period. We go back a quarter of the period just so that we can have a nice set of asymptotes. And then reciprocate our peak, reciprocate our trough. Now our period, we can find algebraically as 2 pi divided by the coefficient b of 4, which is pi over 2. We could also find our period by saying, okay, what's the distance from pi over 4 to 3 pi over 4? 3 pi over 4 minus pi over 4 is 2 pi over 4, which is pi over 2. We can count boxes to show that's true as well. The one asymptote, I mentioned that this is pi over 8 because it's half of pi over 4. So pi over 8 plus, notice, half the period. Half of our period is not pi. So caught me off guard there for a moment. Period should be pi over 2. Okay, this really should be pi over 4n, not pi over 2n. I'm glad I'm going through the notes online, and I'm glad I caught that. So our range does go from -infinity to -1, and then 1 to infinity, and of course, no amplitude. This does get highly repetitive, so our vertical shift, so what's inside equal to 0, and then equal to 2 pi. This in this case gives me pi and 5 pi. So that's my beginning, that's my end. I'm going to first work with a 2 cosine. So peak, 0, trough, 0, peak. Of course, going back 1 so that we can get some nice asymptotes. And then we reciprocate the peak, and then reciprocate the trough, and continue on as much as needed. So one of the asymptotes that you should see is from 0, and then If you remember previous graph, we had something like this happen. Our period does equal 4 pi, which we could see is the distance between those two numbers. So 0 plus 2 pi n. Now feel free to just write this as x is not allowed to equal 2 pi n. So x cannot equal 2 pi n. That's a valid answer. Range goes from negative infinity to negative 3, and then from 1 to infinity. And of course, no amplitude. Last but not least, I did throw a problem that had a coefficient of pi up in front. If you remember last time what happened with the sine and cosine, if there is a pi as a coefficient, it really scales my x values as real number or as integer values, or how about those aren't integers, as nice numbers that don't involve pi. But anyway, equilibrium is going to be 1. So start off with our equilibrium of 1. Then this is going to model a 2 cosine. I set what's inside equal to 0 and equal to 2 pi, and I get the x values of negative 1/2 and positive 1/2. So to scale negative 1/2 and positive 1/2, notice how I spaced it out, and I'm going to strongly encourage that. So from negative 1/2 to positive 1/2. I'm going by boxes of like 4 equal boxes, and I'm doing that intentionally so that I can choose my positive cosine and graph those nicely. And then, of course, since this is a cosine or secant, then we go back a quarter of a period so that we can graph some nice asymptotes. And then we reciprocate the peak and we reciprocate the trough. I actually have some extra periods on here, so let's go ahead and throw those on. So the first asymptote, in case you have a hard time understanding, okay, this is 1/2 right here. So half of 1/2 is 1/4, which is where I get x is not allowed to equal 1/4. And then my period, let's go ahead and do this algebraically. My period is 2 pi divided by that coefficient of 2 pi, so my period is 1. I can also establish that as the distance between negative 1/2 and 1/2 is 1. So my asymptotes are x is not allowed to equal 1/4 plus half n. And then range negative infinity to negative 1, then 3 to infinity. And no amplitude. Last but not least, what we're going to do is we're going to find the equation of the secant and the cosecant graph. The way we're going to do this is just like in graphing. We want to find our equilibrium first. So to find the equilibrium officially, we can average. What's the average of negative 1 and 3? Negative 1 plus 3 over 2 does equal 1. So when I go to write my equations, the first thing I look for is my equilibrium. Second thing I look for is what is the amplitude of the sine or cosine graph? And the amplitude of the sine or cosine graph is 2. So the coefficient or the a value in front of the secant or cosecant is going to be 2. The third thing I'm going to look for is based off of my my sinusoidal wave that I'm modeling it after, which so the sinusoidal wave that I'm modeling after, which one do I want? Do I want a positive cosecant or a positive secant or a positive cosine or a positive, or it's based on a positive cosine, positive sine. So I look at the sinusoidal, right here would be a great place to do a positive sine, which is why a positive cosecant would work here. This would be a great point to use for a positive cosine, which would then be the positive secant. So in this case, if I want to go ahead and start off with the cosecant, then I have no horizontal shift, which is why that's just x. If I wanted the positive secant graph, I am going to be shifting right pi over 2, which is why we see this shift right pi over 2. And then the last thing we look for is what is the period of this graph, because we need to know our b value. So it helps if we look at going from peak, or going from relative max to relative max. That would be a distance of 2 pi. We could see that by 3 pi over 2 minus negative pi over 2, which is 2 pi. And then our b value we find by taking 2 pi divided by the period. So, and we get that because if the period is 2 pi divided by the b value, and the b value is 2 pi divided by the period. So our b value is 1. I guess I have a 1 there. And then we just put it all together for the cosecant or the secant function. So let's talk through that one more time, that the average of -1 and -5 is -3. So that is our equilibrium. Second thing is that distance is 2. So the amplitude of the sine or cosine is 2. So the coefficient of the secant or cosecant is 2. And then if I draw my sinusoidal graph, there we could see that if I wanted to start at the y-axis, then that would be a negative cosine graph, which would turn into a negative secant graph, which is why you see the negative secant here. If we want to start at that horizontal shift, then that would be a good positive sine graph, which would turn into a positive cosecant. So cosine, I said no horizontal shift, which is why it would be a negative secant graph. A shift to the right 1/2 would give me a nice positive cosecant graph. And then how do we find our b value? Our b value one more time is 2 pi divided by the period. And from here to here, that distance is 2. So 2 pi divided by 2 does give me pi. Now you're welcome to distribute that through. So that would be 3 plus 2 cosecant of pi x minus pi over 2. That would be fine. If I really wanted to do this as a positive secant instead of a negative secant, I could have said this is negative 3 plus 2 secant. That's still going to be pi, but now the shift is going to be to the right 1. So we could write that as pi x minus pi. Hopefully you understood all that, and I look forward to working with you on our next one. Take care.